The following information is given in connection with the figure below. EA is equal to 120 volts, EB is equal to 105 volts, R1 and R3 is equal to 1.5 ohms, R2 is equal to 3 ohms, RA 21 ohms, and RB is equal to 6 ohms. Determine the voltages across and the currents in RA and RB using Nodal Theorem Method. For this procedure, every junction in the network that represents a connection of 3 or more branches is regarded as a node. Moreover, considering one of the nodes as a reference or zero potential point, current equations are then written for the remaining junctions node 1 and node 2. Thus, a solution is possible with n minus 1, where n is the number of nodes. Since there are 3 nodes, 2 equations must be written to obtain the currents and the voltages across load resistors RA and RB. Note particularly that node 1 is a junction of R1, R2, and RA. Node 2 is a junction of R2, R3, and RB. For node 1, we write current equations in each of the connecting lines, starting here. We can get the ratio or potential difference in this resistor by subtracting VA and EA and dividing it by the resistance. So we have VA minus EA over R1 plus, moving on to this line, we simply write VA over RA. And lastly, this part we write again the potential difference for this resistor, VA minus VB, and divide it by R2. All set equal to 0. Now we can substitute the given, simplify to remove the fractions, and this is now our first equation. For our second equation at node 2, we start off with this line, VB minus VA all over R2, plus this part is simply VB over RB, plus for this part, VB minus EB divided by R3, all set equal to 0. Substitute and simplify, and this is our second equation. Now solving for VA and VB, we get VA is equal to 105 volts, VB is equal to 90 volts. Therefore, solving for the currents, IA is equal to VA over RA. 105 divided by 21 will give us 5 amps. IB is equal to VB over RB. That is 90 divided by 60. This will give us 15 amps.